Good day, students, and welcome to the mixed review clip on exponents and logarithms. So let's go ahead and take a look at these examples on the right here. We're going to start out with question number 1. In question 1, we're going to simplify the exponent x to the 13 raised to the 9 over 17, 19 over 7. So in this problem, basically, you're going to use the power property of exponents to simplify this. All you simply do is multiply the exponents, okay? So you're going to have x to the 13 over 1 times 19 over 7, all right? And you just multiply the numerators, and then you're going to have 13 times 19 is 247. You can do that with your calculator, over 7. Using the rational exponent property of exponents, we're going to express this as the 7th root of x to the 247. Remember that the numerator is the power and the numerator is the root, okay? So the root goes in front of the radical and then the power stays there. You can write it like this, or you can write it like this. The 7th root of x raised to the 247th power. All right, any of these forms suffice, but this is the form we're going to use because it's consistent with option letter B. So our answer is B. All right, let's move along to question number 2. So for question 2, we are simplifying the expression x raised to the negative 2/3 raised to the negative 3/4. So we're going to use the power of a power property here again. All you simply do is multiply the powers, okay? If I multiply the powers, minus times minus is plus. 2 times 3 is 6. We have 6 over 3 times 4 is 12. So what we'll do next is basically divide the numerator and the denominator by 6. And then that gives me x raised to the 1/2, or the square root of x. Any of these two answers will suffice. So our answer for number 2 is option letter A. All right, let's move on to question 3. Question 3, we're going to simplify the 8th root of 625 b to the 4th a to the 4th. Okay, so to do this, the first thing we're going to use is we're going to use the nth root property of exponents to express this radical as a fractional power. All right, so if we do that, we're going to have 625 b to the 4th a to the 4th raised to the 1/8 power. Okay, now this is a power, this is a power. Can I express 625 as a power? Well, let's go ahead and try it out. So I'm going to have a 625 on the right, and I'm going to try and break this down, okay? So I can take out, since it ends up in 5, I know 5 goes into 625. 5 goes into 6 1, 2 twice, and then it has 1, and then 12, 2, made it 2, 1, 2, 5. This ends up with a 5, so you can take another 5 out of here. You end up with another 25, take out another 5, and then 5. So 625 is basically 5 to the 1, 2, 3, 4, 5 to the 4th power. All right, so I'm going to replace this constant with that. So I'll have 5 to the 4th, b to the 4th, a to the 4th, everything raised to the 1/8 power. I'm going to use my power of products property and a power of a power property to basically distribute this power to all these powers on the inside. Okay, so when I make that distribution, I'm just going to multiply. I'm going to have 5 to the, well, actually, another thing I could do is, well, let's do that. There's another way I can do this, but let's do that first. So 5 to the 4 over 8, b to the 4 over 8, and then a to the 4 over 8. If we reduce 4 over 8, we end up with 1/2, right? So we have 5 to the 1/2, b to the 1/2, and a to the 1/2. Now I can factor out, since all the powers are the same, I can factor out the powers. So I'm going to have 5b a to the 1 over 2. And then using the nth root property of exponents, I can write this as the square root of 5ba. Alright? So there goes your answer. Your final answer is option A. Alright, another way I could have done this, call this method 2. You get the same answer is when we had 5 to the 4th, b to the 4th, a to the 4th, everything raised to the 1/8 power. I could factor out 4 from all these powers right here. So I'll have 5ba, and then the 4 will be multiplied by this right here, times 4/8, which equals 5ba to the, divide by 4 top and bottom, 5ba to the 1/2, and then that becomes the square root of 5ba. Alright, that's another way of doing it, option A. Alright, let's move on to question number 4. Question number 4, we're asked to find the 4th root of 49. So how do we find the 4th root of 49? Let's simplify it as much as we can. We need to express 49 as a power. I can take out 7, so I'm left with 7. So 49 is 7 squared. So let's put that here. Before I can do that, let me also change my radical into a rational exponent. Okay, so if I express this radical as a rational exponent, it's going to be 49 raised to the 1/4. Okay, now expressing 49 as a power, I'm going to write it as 7 squared raised to the 1/4. And using power with power property, I'll multiply the powers. I'll end up with 7 raised to 2/4. Now I can reduce this by dividing by 2 top and bottom. So I'm going to end up with 7 raised to the 1/2 power, or the square root of 7. Okay, so those are your two options. So our answer for number 4 is A. Alright, moving along to number 5. Number 5, we're supposed to find the 4th root of the square root of 1296. Okay, so using the nth root property of exponents, I can express this 4th root as a fractional exponent, namely the square root of 1296 raised to the 1/4. Now this square root here doesn't have a number, so the default number is 2. So I'm going to express this as a rational exponent. This is going to be 1296 raised to the 1/2, and then that raised to the 1/4. Multiply the powers, I'll end up with 1296 raised to the 1/8. Okay? Now, can I express 1296 as a power? That's the question. Well, let's see. For this one, I can break this down as much as I can. So, let's see. I have 1296. It's even, so I can take out a 2. So, take out a 2 from there. I'll have 6. 2 goes in a 9, 4, 1, 8. Take out another 2. I'll end up with 3. 2 goes into 4 twice. 2 goes into 8 4 times. Take out another 2. I'll have 1, 6, 2. Take out another 2. I'll have 81. Keep going. Take out another 2. Actually, 2 doesn't go. 8 plus 1 is 9, so 9 goes in. 3 goes into 9, so 3 has to go into 81. So if I take out 3 from 81, I'll have 27. Take out another 3, I'll have 9. Take out another 3, I'm left with 3. So we have 2 to the 4th, 3 to the 4th. So this problem can be written as 1296 to the 1/8 equals 2 to the 4th times 3 to the 4th raised to the what? Raised to the 1/8 power. Since the powers are identical, I can factor these two powers out. So I'll have 2 times 3 raised to the what? 4/8. Because this 4, when I factor both of them out, I'm just going to times it up here, okay? 2 times 3 becomes 6. 4/8 is 1/2 because you divide the top and bottom by 4. Okay? And then this can also be expressed as the square root of 6. So answer to number 5 is letter A. Okay? Alright. Alright, let's move on to question number 6. On question 6, we're going to solve the exponential equation. 10 raised to the 2n minus 10 equals 1 over 10,000. Okay? The goal here is to get the exponents to have the same base, so we can eliminate by using the appropriate logarithmic function. Okay? So this is 10, so the hint here is, can I express this as the power of 10? 10 to the 10,000 has 4 zeros, so that's basically 10 to the 4th. So I can write this as 10 to the 2n minus 10 equals 1 over 10 to the 4th. Now using the reciprocal property of exponents, I can rewrite this as, just reciprocate this, 10 to the, and negate the exponent to compensate for the reciprocation. Okay? Now the bases are identical, so to cancel out the bases, I'm just going to take log base 10 of 10 to the 2n minus 10 on the right equals log base 10 of 10 to the negative 4 on the left. Okay? This log and the 10 cancels out, log base 10 and this 10 cancels out, so we're going to be left with 2n minus 10 equals negative 4. Alright? To get rid of this, to get n by itself, I'm just going to add 10 to both sides and then divide by 2. Okay, so add 10, we have 2n equals 6, then just divide by 2, and then your final answer, n equals 3. So the answer to number 6 is B. Okay? Alright, moving along, let's take a look at question number 7. That is also an exponential equation. Here it is. So for number 7, we are solving the equation 3n, 3 raised to the 4n plus 3 equals 81. So let's go ahead and take a look at that. So number 7, 3 to the 4n plus 3 equals 81. Now the goal is to express both of these two numbers as powers with the same base. This is already 3, so can I express 81 as a power of 3? Absolutely. Take out 3 from 81, we have 27. Take out 3 from 27, we have 9. Take out 3 from 9, we have 3. So 81 is 3 to the 4th power, right? So we're going to write it as 3 to the 4n plus 3 equals 3 to the 4th power. Now the bases are identical, so I can use log base 3 to cancel out the bases, so I'll be left with the exponents. On the left side, log base 3 of 3 to the 4n plus 1. On the right side, log base 3 of 3 to the 4. Okay? The log n and 3 cancel out on the left with 4n plus 3. On the right side, the same story, left with 4. To get n by itself, we just subtract 3 and divide by 4, and that'll give us our final answer. Okay? So subtract 3. 4n equals 1. Divide by 4. N equals 1 over 4, and that's it. Our answer is option C. Alright, let's take a look at question number 8. We are supposed to match this exponential function, y equals 8 times 4 to the x with one of these graphs. If I just pick two test values, namely 1 and 2, make a chart, and that should be able to help me solve the problem. Okay? So let's just make a table. I'm going to just test two values. That should be sufficient to help me determine what the correct answer is. So for my input, I'm going to test 1 and 2. I'm going to plug them into the function y equals 8 times 4 to the x. So for the first one, it's going to be 8 times 4 to the first power. 8 times 4 is 32. And then for the second one, it's going to be 8 times 4 to the second power, plugging in 2 for x in the function, which is 8 times 16. 8 times 16 is 80 plus 64, which is 144. Okay? Alright, so let's see which one matches. If you take a look at the graph, you notice that this one, when x is 1, well, actually, this is a straight line. So this is not a linear function. This is an exponential function that should go up like this. Okay, so it cannot be the line. So A is not an answer. Let's take a look at option C. When x is 1, y is around 32. That's a dead giveaway that our answer is option 1. Okay, that this is one of the options, a good candidate. And then when x is 2, it's 144, way off the chart. Let's look at this. This is wrong because when x is 1, y is probably 4. Which is wrong. And then option D, when x is 1, y is way off the chart, definitely not 32. Well, yeah, so we can see clearly that our answer is option letter C for number 8. So our answer here is option letter C. Okay? Alright. Now, let's take a look at question number 10. Actually, let's look at 9 first before we do 10, okay? So for number 9, we're going to solve the equation log base 5 of x plus 2 minus log base 5 of 7 equals log base 5 of 49. Okay? Now we're going to condense these two logarithms using the quotient property whenever you have subtraction. Remember, subtraction means to divide the arguments, and then addition means to multiply the arguments. Since we have subtraction here, so we're going to divide. So we have log base 5. We're going to be dividing x plus 2 and 7. So log base 5 of x plus 2 over 7 equals log base 5 of 49. So to get rid of the log, we put a big 5 on both sides. And then a little log base 5 of x plus 2 over 7. And on the right side, a little log base 5 of 49. Okay? These ones cancel out in their inverses. So we're going to have x plus 2 over 7 equals 49. Okay? Now, to get x by itself, we will multiply both sides by 7. Multiply by 7, multiply by 7. This one divides out. We'll have x plus 2 equals 343. Subtract 2 from both sides, and then we'll have x equals 341. Okay, so that goes your final answer. Alright, moving along, let's take a look at question number 10. It says the amount of money A accrued at the end of n years when a certain amount P is invested at a compound annual rate R is given by A equals P times 1 plus R to the n. If a person invests 200 in the account and pays 6% interest compounded annually, find the balance after 15 years. So the balance is basically A, the amount of money you have left. So A is going to be principal invested, 300, times 1 plus the interest rate R is 6%, so we have to write it as 0.06. And then the number of years is 15. Okay, so this becomes 300 times 1.06 raised to the 15th power. And then we're going to plug that into our calculator and see what the output is. So it's going to be 300 times 1.06 raised to the 15th power, and the answer is 719, approximately 719. So the amount after 15 years is approximately $719, which is option letter D of number 10. Okay, now let's move on to question number 11. Question 11, it says which log expression is equivalent to log number 11, let's write it down. Equivalent to log base 2 of 4 plus log base 2 of 4 minus log base 2 of 6. So remember, when you're adding the logs, it's equivalent to multiplying the arguments. And when you're subtracting the logs, it's equivalent to dividing the arguments. Okay, so we have a plus here, so we're going to multiply these two arguments right here. So it's going to be log base 2 of 4 times 4. Since this has been divided, we're going to divide by this because of the minus divided by 6. This is going to be log base 2 of 4 times 4, which is 16 over 6. 16 over 6, and we can divide this out with our calculators to get the approximate result. So 16 over 6 is 2.6 repeating. Okay, so our answer is going to be log base 2 of 2.6 repeating. So our answer is going to be option letter A for number 11. All right, let's move on to number 12. We're asked to condense this logarithm. So let's go ahead and do that. So for number 12, we have log base 6 of 5 plus 3 log base 6 of y minus log base 6 of y minus 2. Now, this logarithm is not uniform with the others, so we need to get rid of these 3 so that it's uniform, and then we can condense. To do that, we're going to use the power property of logs to power of this exponent. So it becomes log base 6 of 5 plus log base 6 of y to the third minus log base 6 of y minus 2. Okay? So remember the rule, when you're adding logs, you multiply the arguments, and when you're subtracting logs, you divide the exponents, the arguments, okay? So let's do that here. We're going to have log base 6 of 5 times, this one will be multiplied with this one because of the plus, 5 times y to the third, and then divided by that because of the minus over y minus 2. So the answer for number 12 is C. All right, let's move on to question number 13. We're asked to find x. Let's make a real quick sketch right here. It's always good to mark your triangle as much as possible so you can know where your opposite is and all that cool stuff, okay? All right, so there's a sketch of my triangle. This is the right angle. This is the reference angle 42. 15, and that's x. Okay, so let's label our triangle. Since this is the reference angle, that means the side opposite it. This is the opposite, which is O. The side opposite the 90-degree angle, the biggest angle, is the longest side, known as the hypotenuse. Okay, this is the adjacent. I don't need it. I don't know it, so I scrap it. It doesn't count here. So I need O and H. So in SOHCAHTOA, which one has O and H? Sine, right? So we're going to write sine 42 equals opposite, which is x over hypotenuse 15. To get x isolated, we multiply both sides by 15. So x is basically 15 sine 42. Okay? Alright, let's plug that into our calculators and see what we get. We have to make sure our mode is in degree form first, or else we're going to have an error. So it's already in degrees, so I'm going to do 15 sine 42, and the answer is 10.0261, or 10.04. So the answer to number 13 is basically x equals 10.04, which is option letter C. Okay? Alright, moving along to question 14. Question 14 is similar to question 13, so I'm going to skip that one. I'm going to jump to question 15. It says convert 9 degrees to radian. So if you're converting from degree to radian, either you multiply by pi over 180 or 180 degrees over pi. Since this has a degree, I have to pick the option that has a degree on the bottom, right? So this one will work. So put this over 1 multiplied by pi over 180 degrees. Okay? And this is going to be radians. Now, the degrees cancel out like we desire. And we have, this becomes 9 pi over 8 over 180. I can divide the numerator and the denominator by 9, right? So if I divide the numerator by 9, it becomes 1, which is pi, over 20 radians. Okay? So the answer to number 15 is B. Alright, let's take a look at number 16. Similar to this one, just to get more practice, we're going to convert 450 degrees to radians. So for 16, we have 450 degrees. So if I want to convert it to radians, I multiply by pi over 180 degrees again, because degree on the top, I need a degree on the bottom so they can cancel out. And then we'll have 450 pi over 180. Okay? The zeros can be cancelled out by dividing by 10, divide by 9 top and bottom. And that yields 5 pi over 2 radians. Okay? So the answer to number 16 is D. Alright, let's take a look at 17. It says we're supposed to use log base 4 of 3, which is approximately 0.7925, and log 4 base 4, which equals 1, to find the approximate value of log base 4 of 48. Okay, so the rule of thumb here is to express 48 using these two logarithmic values that we know. Okay, so how do I do that? I just use my factor tree and break 48 down using a combination of these two numbers. I can take out 3 because I know 4 plus 8 is 12 and 3 goes into 12, so 3 goes into 48. 3 goes into 48 1, 18, 6 times, and then 4 goes into 16 4 times. That's good enough. So log base 4 of 48 is the same thing as log base 4 of 3 times 4 squared, because I have two 4's. Okay. Now, when you're multiplying the arguments, that basically means we're going to do the sum of the logs, right? So the sum of the log of 3 plus the log of 4 squared. All right, now I can power down this exponent, so I can plug in this approximate value. So I have log base 4 of 3 plus 2 log base 4 of 4. Now log base 4 of 3 is 0.7925 plus 2 times log 4 base 4 is 1. So we're going to have 0.7925 plus 2. Actually, this is an approximation. I can't make it equal. Is approximately 2.7925. And the answer to number 17 is D. All right. Let's move on to question number 18. In question 18, we're asked to do the following. All right, so number 18, it says the projected worth in millions of a large company is modeled by the equation y equals 241 times 1.04 to the x. X represents the number of years since 1997. What is the projected annual percent of growth? And what is the company's worth in 2001? Okay, so I want to find the r first. So let's write down the general formula, which is y equals a times 1 plus r to the t. Okay, so the initial amount, starting amount A, is 241 million. The rate is what you're adding to 1, right? So what are we adding to 1 here? We're adding 0.04 to 1. 0.04 is the same thing as 4%. Okay? And the time is equal to x. And it's how long, we're going from 1997 to 2001, right? So how many years is that? It's 2001 minus 1997. Do the subtraction, is 4 years. 4 years. Okay? And then the final amount is also something we're asked to find. Now, what's the growth rate, first of all? What is the annual percent of growth? This is the percent of growth. So annual percent of growth is 4%. Gotta be careful. That's 4%. Now, to find the amount after 4 years, you're going to plug in 4 into this formula. So 241 times 1.04 raised to the 4th power. Okay, so that will help us compute the final amount. So plug that into the calculator. 241 times 1.04 raised to the 4th power. Answer is $281.94 million. So the company is going to be worth $281.94 million, and that is option letter D. All right, let's move on to 19. It says the number of bacteria present in a culture after 2 minutes is given by B equals 10e to the kt. If there are 6,703 bacteria present after 5 minutes, find K. So let's do that. Let's write down the formula. B, which is the final amount, equals 10 e to the kt. Now I know that the final amount B is equal to 6,703. The time is 5 minutes. The decay constant K, the growth constant K is what I'm looking for, so it's question mark. All right, so let's plug this into this formula and solve for k. So we're going to have 6703 equals 10e to the 5k. All right, so first step is divide both sides by 10. And that's going to give us, it's going to be 670.3 equals e to the 5k. I just know the decimal point forward once. If you don't know how to do that trick, you can just give it up with your calculator. You just do 6,703 divided by 10, which is 670.3. And then to get this power down, I'll take the natural logarithm of both sides. So the natural logarithm of 760.3 equals the natural logarithm of e to the 5k. Okay? Now, on the right side, the natural logarithm and e are inverses, so they cancel each other out. So I have 5k, using the reflexive property of equality, equals the natural logarithm of 670.3. So isolate 5, I'll just isolate k, I'll divide both sides by 5. So I'm going to end up with k equals the natural logarithm of 670.3 over 5. Okay? And we just plug that into a calculator to see what we get. So the natural logarithm of 670.3 divided by 5. And the answer is 1.302. So B is going to be 1.302. Okay, so there you have it. Actually, that's k. That's a growth constant k. Okay, so k is 1.302. All right, now that's that. Now let's move on to the short answer. Question number 1. We're told that exponential, it says write an exponential model to estimate the value of a function after 5 years, a population of 250 animals that increase at an annual rate of 19%. So we have an annual rate, so that tells you it's discrete, and it's growing, so it's discrete growth. So we're going to use the formula. This is for short answer. Short answer number 1. We're going to use the formula y equals a times 1 plus r to the t. Okay? All right, the initial amount a that you're starting with is 250. The growth rate r in percent is 19 over 100, which is 0.19. Move the decimal point forward twice because there are 2 zeros. The time is 5 years. Let's write down the model first. The model is what is the equation for any arbitrary t. So this is the model. The model is y equals 250 times 1 plus 0.19 to the t, which can be simplified further into y equals 250 times 1.19 to the t power. Okay? Now, so what is the population after 5 years? So after t equals 5, we're going to have y equals, just plugging 5 into the model, 250 times 1.19 to the 5th power. Plug that into your calculator, and that will give you your answer. So we have 250 times 1.19 raised to the 5th power. The answer is about 597, because we have to round it to the nearest whole number. So y equals 597. All right, let's move on to question number 2. It says, write an exponential function to model the situation. But that's similar. Let's skip that. Let's go to number 3. Number 3 is find the reference angle for 309 degrees. So let's go ahead and graph 309 degrees, negative 309 degrees. Now you remember that when the angle is positive, you go counterclockwise. If the angle is negative, you go clockwise. Okay, this is positive, this is negative. So since this is negative 309, we're going to be going counterclockwise. I'm sorry, we're going to be going clockwise. So negative 90, too small, keep going, negative 180, too small, keep going, negative 270, too small, keep going, negative 360. We went too far. So the terminal side for negative 309 is going to be somewhere in the first quadrant. Okay, so this angle, negative 309, is the angle swept by rotating from here clockwise to there. Okay, but what's the reference angle? Is the angular measure of the terminal side to the nearest x-axis. Okay, this is the nearest x-axis. So what is this angular measure? What is it measure? So how many degrees? Forget about the sign here because reference angles are always positive. How many degrees is there? Degrees of separation is there between 309 and 360. To do that, we can just simply compute 360 minus 309. Okay, 1. So it's 51 degrees separation. So this answer right here, 51 degrees, is your reference angle. All right, let's take a look at the last question. It says simplify 1 over 16 to the 1/2 power. So there are two ways of doing this. I can do this using radical. So let's use radical method. Okay, so I'm going to express this as a square root of 1 over 16. Using the properties of radical, I can break this to the numerator and the denominator. Square root of 1 is 1, and the square root of 16 is 4. So our final answer is 1 over 4. Okay, so that's one way of doing it. Let me show you another way of doing this for this page first. I wanted to do the same problem, method 2, without using the properties of radicals, just properties of exponents. I'll write 1 over 16 raised to the 1/2. Now I'm going to write 16 as a power, so break it down. 2 goes into 16 8 times, 2 goes into 8 4 times, 2 goes into 4 2 times, so 16 is 2 to the 4th. So I'm going to write this as 1 over 2 to the 4th raised to the 1/2. Okay, and now I'm going to distribute this to the numerator and the denominator using the quotient of powers property. So I have 1 to the 1/2 divided by 2 to the 4 over 2. Okay, 1 to the 1/2 is the square root of 1, which is just 1. And 2 to the 4 over 2, divide the top and bottom by 2, you have 2 squared. Okay, that becomes 1 over 2 squared is 4, so your final answer is 44. Okay, so there you have it. Well, thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel just by clicking up here. More videos can be found on mygoodchef.com. Thanks again and have a wonderful day.